First thing, where have we seen symmetries in the problems that we've looked at so far? Anybody give me one place where symmetry has arisen?
Question 20 and 21 mentions something about symmetry.
Is that the one with the circles?
Yeah.
Yeah.
Okay. So we're trying to figure out how many points with integer coordinates lie between two circles centered at the origin, right?
Yeah.
So how could you approach this problem?
We'll only count up all of the integers in a quadrant and then multiply by 4.
Okay, why can you do that?
Because it's the same all the way around.
That means there's a symmetry involved.
Yeah.
That's a symmetry. Okay? So you have two radii, different people had different radii, right? And you can list, for example, if these are your integers, right? Then you could list all the integers along this vertical line, all the integers along this vertical line, and so forth, right? Okay? And you would also have these points over here that would give you intersections. So, and all the points, I think I drew too many of them, but this point, this point, this point, this point, this point, this point. What about this one?
No, because it's not in between.
Well, that's where you would have to use the Pythagorean Theorem to see if that point is too far from the origin, right? Okay? So you would try to find 2 points up here such that one is at less than this distance from the origin, right? Okay? And one is at a distance greater. Then you know how many points would lie along this line, right? That's one strategy. You could use that, okay? Now you could take every point of the plane in this whole grid right here and test it, right? But that would be kind of silly. Okay, some of them you can just tell for sure that they're going to be closer. For example, all the points here, right? On the x-axis, all these points here on the y-axis would lie at the distance. But you have to make some decisions out here. Now, it's still got to be a little bit of work, right? Depending how big the numbers are. I didn't give you any really big numbers, okay? Does everybody understand what I'm talking about? Is that pretty much what you did? Okay? You would know to do that. So that would be one strategy. Now, would it be reasonable to do that for every quadrant? Well, no, every quadrant is going to give you exactly the same result that this quadrant would. Assuming you don't mess up and count all the points on the x-axis and the y-axis, right? You would count only one axis. And you can think about why. Okay, but that's an example of symmetry. And the whole point is, the question is about symmetry. Okay? So the way you would use symmetry here is just that all 4 of these quadrants are identical, so what happens in one is going to happen in every other, right? So, I'm not going to get into a formal definition of symmetry, although we might. And if we don't, well, you're going to see it in pre-calculus or analysis anyway, so I don't need to necessarily teach you that, but I might tell you if it's relevant to something we need to do. Okay? Now, where's another place symmetry occurred?
Any geometrical shape.
The what?
Any geometrical shape.
Well, there are a lot of geometrical shapes that aren't symmetric at all.
I mean,
An exponential curve is not symmetric with anything.
yeah.
But Okay, well, I'm just gonna tell you, and it's gonna be obvious, so obvious you probably didn't think of it. What did I just draw?
Triangle.
Um, Assume this side is parallel to the x-axis and this side is parallel to the y-axis. What is this?
The fundamental triangle.
Fundamental triangle. Is it the only possible fundamental triangle?
No.
Okay, well, yeah, there's another one here. Now, is there any symmetry involved in this?
Yeah.
Yeah.
Well, you just reflect this over here. This is a piece of paper. You could fold it along the hypotenuse, and this one would coincide with this one, right? So there's another symmetry, right? Okay. Okay, any place else that symmetries have occurred? Or the word symmetry? Well, nobody noticed it. It's okay at this point. It's going to come up. Okay? That's kind of what I mean by symmetry. Let's take, how about this one? 1, 4, 6, 4, 1. Is there symmetry in that set of numbers?
Yes.
Pardon?
Yeah.
Yes.
Yeah, symmetric about the middle, right? What you have to the right of the middle is exactly what you have to the left of the middle. Okay? Now to really say that rigorously, I'd have to add a bunch of words, but you have the idea, right?
Yeah.
Okay? How about this graph?
Yeah.
Yeah.
Yes.
Yeah, anybody know what you call that graph?
Bell curve.
A bell curve. It's a graph of a certain function, the normal distribution.
68%, 95%, 99.7%.
I'm sorry, can't quite hear you. Okay, I'm confusing my letters here. Graph of the normal distribution. And we're actually going to encounter that today. There's a formula for it. You can easily evaluate it on your calculator, okay? We're going to save that for a little while. So, those are examples of symmetries. What about a parabola?
That works. Yeah, because there's a symmetry about wherever it meets. I guess it would be the origin, usually.
Parabola could be anywhere.
It could be anywhere.
So I just draw one out here in the middle of space. And here's the vertex. If the parabola opens vertically, okay, there's the vertex, and there's the line of symmetry, right? So if this is a parabola, it's supposed to be a parabola. I didn't get the symmetry quite right, did I? So I'm a little skewed there. But assuming this represents an actual parabola, you have the vertex, and you have this line here, right? What do you call that line? Well, you might or might not have seen that terminology, but you're going to see it now. This is going to be really mysterious. You're not going to understand a word of this. This line is going to be called the axis of symmetry. Well, yeah, you do understand what I just said, okay? You understand why we call it the axis of symmetry, right? What about a cylinder? This is a kind of a, looks like a dirty cylinder. It's not all that dirty, that's just chalk stuff there. Perfectly sterile. Well, there's some water in there and there's probably mosquitoes brooding, but you know how it is. Okay. Is there symmetry here?
Yeah.
Yeah.
Is there an axis of symmetry?
Yeah.
What would you think the axis of symmetry would be?
The middle area, like the middle of the circle. Because then it
It
would
would be like right here, right?
Yeah.
Yeah.
Okay. Now for this actual cylinder, you could say that there's a plane of symmetry right here. It's the same above that plane as it is below the plane, right? Or any plane through the axis of symmetry will be a plane of symmetry. Well, if you understand what I said, great. If you don't, it's no tragedy at this point, okay? Does that make sense? Okay, so there are all kinds of symmetries, and symmetries are really important in mathematics, so it's worth noting, right? Everybody understand a little better what the idea of symmetry is and how it might be useful?
Yeah.
Very useful here because it cuts down your work a lot, right? Useful here, if you can prove these triangles are congruent, then you've proven that the hypotenuse is part of the axis of symmetry, right? Or that the line through these points is an axis of symmetry for these two figures. And symmetric graphs are very handy because if you calculate something on one side, you know that the analogous calculation is going to come out the same on the other, and you don't have to do it twice. Okay? So, pretty handy idea.